Yeah, welcome to our next program track. Thank you for joining us. We will continue in this stage at the Technikum with the track Internet of Things, critical applications and use cases. We have a number of use cases to show. I'm very happy that so many of you agreed to explain their different cases, and the idea of this session was to offer hands-on, very practical examples of, in this case, Internet of Things applications and use cases. But the session will be opened by a gentleman who will give us a little journey over the latest developments in the Internet of Things. Ladies and gentlemen, please welcome Martin Lüers from Roland Berger.
I use this one or this one?
You can use either one.
Yeah. All right. Yes, thank you very much, Mr. Möhring, for the kind invitation. As said, I was asked to give a little frame for the session. We do have a lot of thoughts around the industrial Internet of Things, like many companies nowadays. And I summarized a couple of slides to give a short speech around these developments. And they are mainly centered around three topics or theses. So one is we do see or foresee also a lot of disruption through the industrial Internet of Things, mainly because they enable new business models and services. I have a couple of high-level examples here. I see in the use cases there are many more. And I will also discuss how we see these ecosystems, how do they look like. I'm pretty sure not everyone is familiar here with that, and what the impact is. Then we also see a lot of platforms developing and emerging, a huge number of platforms, and other industries show that there is quite a strong consolidation tendency because of meaningful reasons for that, and that's most likely also happening in the industrial Internet of Things. I don't have the magic ball, so I can't tell you what the exact platforms will be in the different verticals, but there are a couple of tendencies around that. And the next one is especially for our customers. I work in engineered products and high tech in the competence center, so have a lot of clients from the industry space. How should they focus and what should they do? Just giving that very briefly. So let's start with what the ecosystem looks like. And we mainly see 5 layers in the industrial Internet of Things, and see these layers also across the verticals. So starting with cloud service providers, the usual names, Amazon, Microsoft, Azure, also lots of smaller companies developing around there. We have a lot of industrial cloud platforms emerging, very prominent ones, Siemens, MindSphere, GE Predix, but also smaller companies, or now smaller companies like Relayer or larger ones, C3 IoT, who develop platforms to just allow connectivity of equipment in the different industrial verticals. And in these, obviously, in the cloud platforms, we see apps, the layer actually providing the value of the IoT to the different end users. So very important to attract. And they obviously can't be involved in every platform, which will also be a tendency of consolidation. So this is the third layer. The fourth layer are the OEMs, the Siemenses, also the smaller equipment manufacturers who actually connect their equipment, and that is then used by certain end users. We think in this logic of the 5 layers. You see, this is, although I'm at TechDays, that's not a technical layers. These are business layers. But I think they explain nicely how the ecosystem looks. And we can also see why the IoT is such a buzz currently, because it does enable a couple of disruptive elements. I've named already the business models. So we see from traditional selling equipment at a fixed price to many more pay-per-use models, which is very attractive for a lot of customers because they don't have to burden the cost of equipment at the very beginning. But we also see a lot of digital services, predictive maintenance, vendor asset monitoring. We see a couple of these in the use cases that really provide additional value or take out costs in the ecosystems, which makes the IoT so powerful and the connection of equipment to the cloud so powerful. And what we also see is that in these layers there are hundreds, literally, of companies currently developing. The traditional ones, you see them below, using manufacturing equipment. That's what I used here as an example. OEMs talking about or already connecting their devices through platforms, and that's one of the focuses of this discussion, that's why I highlighted it here, which also develop rapidly, and I still see just an increase in platforms. And actually just before this speech, a startup company, software developer came to me and asked me, which platform should I focus on? And I don't have, for this specific application, I don't have the answer, but the topic is, it can't be that all these platforms will at the end survive. And this will be a topic I will discuss later on. But currently we see lots of platforms emerging, also billions of investments in there, and a lot of our clients asking themselves, should I develop my own platform? Should I partner with another company? Where should I go? So looking, actually, I think that's the best example at the smartphone industry, where we also see a strong development of platforms. That's, for me, one vertical. It's the consumer vertical. We had a couple of competing platforms in the end of the 2000s. And then Apple came, everyone knows that, with a very attractive software development kit with a first mover advantage and starting to disrupt the market with smartphones. But Google actually was it with Android, who provided an open platform, attracting a large developer ecosystem, and also device OEMs, so not just Apple, but many others, and now has 80% of the market. So it's not as drastic as in the industrial sphere, but there were a couple of platforms established, but it's pretty much two now, and one being very, very dominant around the world. So what does that mean for the industrial Internet of Things? The IoT is a bit different. The industrial IoT is a bit different than the smartphone, where you have one device and a lot of users, or one type of device. So there are very differing requirements, and I think this is also why currently the developments are so unsecure and so many platforms evolve. Let me start with the end user. So a typical, let's take again manufacturing, a typical manufacturing end user like a Kellogg's, a BASF, and so on, they have a large park of equipment, and they want their equipment to be connected to an IoT platform, but they don't want to use all the platforms of all the suppliers that they use. So large companies like BASF, for this reason, develop their own platform again, because they don't want to handle all the platforms of the other companies. The OEMs have a different rationale. They see the industrial Internet of Things as a means to create additional value for their customers, obviously mainly focusing on their equipment because that's what they're selling. And many of these try to be open, but at the end it's very focused towards their equipment. The third is the developers already touched on these. They require a platform that just helps them to create a sustainable and high amount of revenue for their apps and the developments that they do. And so what you can see is, and that's the thesis that we do have a lot of diverging interests. But at the end, it is most likely that in the vertical industries, like manufacturing, like energy, like building, you will see a couple of leading platforms doing a similar consolidation, most likely not to the same extent, but doing a similar consolidation that we saw in the industry, in the smartphone world. And we also see that there are a couple of companies having an advantage. One, the companies that are already very dominant in these ecosystems. For example, in energy, GE is quite good in attracting developers because they have quite a large installed base. Something similar could happen also in industry with other large corporations, and a couple of first movers, obviously, who can disrupt the industry. So what does that mean? Focus is very necessary, especially for the companies who don't have the resources of a large company. We usually think in a way of structuring it along the IoT stack, and along the verticals. And if we discuss with our clients where and how should you play this game, it's mainly centered around where do you really add value? Are you a device manufacturer or a component manufacturer? In which vertical do you add value? And at what layer do you add value? And make sure that you partner for the rest. And these partners, obviously, especially in the platform game, should be the ones that have a tendency or that are most likely to win in this specific vertical. But this structure helps us a lot to start a discussion around what should your role be. Good. Thank you very much. I hope this was a short inspiration. I'm looking forward to further discussing that. And thank you very much for your attention.
Thank you very much, Martin. Thank you very much. Is it on again? Yeah. Thank you very much. I think we open the floor for our next speaker, Aurelius Wosylus from SigFox, one of the real infrastructures for IoT. Ladies and gentlemen, please welcome Aurelius Wosylus. Meanwhile, I will have to flight start his presentation from the USB stick. Wosylus. Hey.
Besten Dank. So good morning to everybody. My name is Aurelius Wosylus. I'm 15 years in the embedded IoT market. I'm heading up the organization from SigFox, which is a IoT wireless connectivity provider active in 32 countries at the moment. Seeing the last presentation, the last slide, I'd like to turn around the picture a little bit. Everybody is talking IoT platforms. The IoT platform, the software, is not the challenge. What we see all the time is that the customer is coming to us and say, what device is available which I can attach to my application? That's the biggest issue which needs to be solved in this market at the moment. Why? Because the market we're addressing is not addressed today. Everybody is talking disruptive. I'm not that sure it's a really disruptive market. It's just a market where no application, no technology fit before. Now we have this technology and we can address this market. Okay, let's start with the presentation. So to address the market, there needs to be some new technologies available. Key topics is, or let's say the existing connectivity on the market is wired internet technology, local networks, GSM mobile phone technology. We all know these technologies do not fit to all applications. Let's say the 20-euro coffee machine, you cannot put in a GSM technology because the price level doesn't fit. Just one topic. So what we're doing, we're bringing in a low power wide area network. So it's very cost efficient, very low power, wide range, global. The market we're addressing in these LPWAN area is the blue one. The blue one is the market which is not addressed today. Why? Because all the other technologies did not fit into that market. So there is the wooden Euro palette, there is the 20 euro coffee machine. Now there is a technology available which fits in exactly this market. And think about all these sensors flying around in the world which we can now connect to the internet. Now thinking big data. Where is the big data coming from? Mainly sensors. Now we can connect the sensors. So all the Intels, the Oracles, they will be happy to get all the data to their databases to process them, to do predictive maintenance and so on. So a short summary of the company. Today, 2 million square kilometers are covered with our network, which is about 500 million people in 32 countries. 12 countries are rolled out completely. 20 million devices are booked, so it's a moving technology, a proven technology. It's nothing new. And we're on the market since 2010, so we're 7 years old. Still a startup because we're venture capital financed still. And the idea is to have a global network where is no roaming cost, it's one network. Wherever the devices are, they broadcast, which is a difference to GSM technology. They broadcast their messages to our network. We get the messages from our base stations, small, tiny antennas, put that into our cloud, and then we push them over to any IoT system out there. Whoever wants to connect, even students can program their own software. We're happy to connect. Of course, on both sides, on the object and on the IoT management device or system, we need to have a huge ecosystem because the requirement on the device side it's huge. There are thousands of different requirements. Temperature proof, shock proof, form factors, battery lifetime, robustness, environments which are unusual, let's say. And of course, every company has a different requirement on managing the data, partnering with partners, or giving, let's say, generating mobile apps. So as I said, we're active in 32 countries. I started with SigFox in March last year. And from mid last year to today, we covered the network, with our network, 51% of the German population, which is pretty quick when you think about how long it took to roll out the GSM network. We did this in 12 months. End of this year, we will have coverage of 85% of the German population. End of next year, it'll be 95, which is more or less full coverage. Just an overview of the partners. Semiconductor guys, module makers, application builders, IoT system builders. This is just an extract of our website. I think there are 500 partners which are presenting themselves on our site. Talking a little bit technology. There are a lot of wireless technologies out there. There are global reaches, there are local networks, there are private networks. Why is there a big difference between all of them and SigFox? First of all, our devices, or the devices, send out the message as a broadcast. Means all antennas we installed will receive the message. For example, in Munich, 18 antennas, when you send out the message here, probably 12, 10 antennas will receive the message. It's multi-redundancy. Then, in addition, we send every message 3 times. On different frequencies, we call this channels, on random time spots. So nobody can understand or predict what time slot the next message will come. So it's really redundant. The other topic is, that's why we call this technology ultra narrowband. These peaks are very high. So it's, let's say, for translation, it's very loud but very short, because the limitation in the European countries is to put 25 milliwatts in the message. That's the maximum you're allowed. But this message needs to come from deep indoor, means the smart meters in your heating system, but also, we like to receive that, but also from a far area. Rural countries or rural areas, the reach of this technology is between 50 and 70 kilometers radius. Now we talk about volumes. As I said, the volume is huge in the IoT market. It's much larger than GSM, LTE together. There are analysts which says 50 times up to 100 times larger or bigger. This means we need to have antennas or base stations which cover or can get more and more data or can manage more devices than a normal base station. So one base station from us can manage 1 million devices without any problem. And we can densify the network just putting additional antennas in the region. So the big difference, completely royalty free, so we don't charge for license. No SIM card management. One SIM card management is about 12 euros. Pretty simple to integrate. No private rollout of a network. You don't, as a customer, you don't need to install any antennas. Low subscription cost per device. Verbally, we say between 1 and 8 euros per device per year worldwide. No roaming cost. Price and service scalability, we don't care if it's one device or 1 million devices sending, but the big topic is no network maintenance. So the customer do not need to take care about the backend infrastructure, how to manage the devices, or the antenna network. As an example, this is the antenna. This is a base station. It's the size of a Wi-Fi router. And that's all I can tell for today. Thank you.
Thank you. Thank you so much, Aurelius, for this overview on SigFox. I think we will touch upon one of the issues you mentioned. Security is the main concern of our next speaker. Ladies and gentlemen, please welcome Stephan Spitz from Giesecke+Devrient. He will highlight the IoT perspective from the security point of view. While I start his presentation, I will hand over to him. Please welcome Stephan Spitz.
Thank you so much. Thanks, Peter, for bringing me on short notice into your conference. We are colleagues working close together at GND, and actually it's very nice that we have this presentation before on SigFox, because I want to give you a little bit more background, also from a technology standpoint. What is low power wide area technology, and what security-wise matters in such low power wide area IoT infrastructures. So first of all, I can only, here we see the first connected internet thing was actually a Coke machine, 1982 already. So Internet of Things, connected devices is nothing really new. We have it since many, many years, even when it was not called IoT before. But what I present to you today, and what also was presented in the previous SigFox presentation, is a brand new IoT technology, the so-called low power wide area IoT technology. The low power wide area IoT technology is a strong driver in the market for connected devices, because it offers connectivity for long range at very cheap costs, as previously presented. So it will boost up the number of IoT devices which will be connected. So when you look here, the forecast to 2020 is in the range of 50 billion connected devices. This cannot be only cars, coffee machines, or industry manufacturing plants. This will be smart sensors, will be water sensors, heat sensors, in the agriculture area sensors. So this is really, these small sensor things will boost the IoT market in future. And these sensors need security. So here I have a little bit of comparison, maybe a little bit a different way to present what SigFox presented, but it shows you the advantages of the IoT, low power IoT technology. So on the left-hand side, here you have low power wide area IoT technology in comparison with on the right-hand side the classical 2G, 3G, 4G LTE networks. So low power wide area technology covers really an extreme long range. So we have 30 kilometers and even beyond 30 kilometers range. This is never reached by a 2G, 3G, 4G network, but this is paid off by a low bandwidth. So you can only transmit a few bytes of data. You cannot send internet traffic over such a connectivity range. An additional advantage is of this technology the long battery life of these devices. So a device should survive 10 years and even longer with one battery pack, because when you go in agriculture use case or use cases where you simply have no additional power supply, a battery needs to be used in a very careful manner. An additional thing is the low cost of these low power IoT devices, which will definitely boost the market. We are speaking of devices which are far beyond 10 euros costs. We speak about connectivity costs which are per year far below 5 euros. So you see you're in a totally different cost range than an internet provider, for example, has. We speak also about very, very robust devices. These devices have to survive in environments like in the tarmac on the floor for many, many years. So it needs to be a robust device. And last but not least, a very important feature is the deep indoor penetration. So with low power wide area IoT technologies, you can send data through walls. Even when you have a sensor in the cellar of a house, it's in the most cases reachable. A classical Wi-Fi connection or a cellular connection cannot reach such a deep indoor penetration. So new use cases are also enabled because of these specific characteristics of low power wide area IoT technologies, where, by the way, SigFox is one of them. So here I have a little bit a comparison regarding the range and the bandwidth. So the bandwidth is very, very limited with a low power wide area IoT, but the range is extreme. So even a Bluetooth connectivity or a Zigbee connectivity has a higher bandwidth than a low power wide area IoT device. But for certain use cases, such as smart metering data, this does not matter too much. And on the other hand, you have the long range. So for those from you who are engineers, it's quite easy. The energy which is invested in 1 bit to transmit is a much higher energy than with a wireless LAN standard, for example. This allows this long range. So you have a very robust long spreading in the spectrum. What else? So yeah, I think most of the topics here on that slide I've mentioned. By the way, expanding this a little bit, low power wide area IoT will be in 5G, in very important technology. It will be in the IoT slice, in the long range IoT slice. So we expect also from G&E, from our technology assessment, that this technology has definitely a bright future. There are 2 ways to do low power wide area IoT. There's the one in the unlicensed band, in the unlicensed spectrum, where we have the company SigFox, where we have companies such as consortiums such as LoRa or Inchino in the US. And there, as previously presented, in the 86.8 megahertz or in Asia or US 915 megahertz band. And these bands are license free. So these bands are not operated by the MNOs, large mobile network operators. Everyone can send data in this band, which is definitely a low hurdle for deployment. So the hurdle for deploying base stations in this environment is very low, even if you have several regulations in different countries. These technologies have different security levels. So SigFox, LoRa have different security technologies. I have to say the security technology is not too bad with all these technologies, but it's brand new. It's not like the security in the mobile networks. In the mobile networks, you have security solutions such as SIM cards, encryption on the air interface, which exists since a very long time, which are hardened also from the key management and cryptographic aspects. The technologies are brand new. As said, LoRa, SigFox are companies which exist since just a few years, and they have had tremendous progress. When you look at their coverage maps, for example, the coverage is really amazing. On the other hand, we have another low power wide area IoT technology, which is the narrowband IoT technology. Narrowband operates mainly in the license band. It's a 700 megahertz technology. It can go up to the 2.7 gigahertz. It can be operated only when you have acquired the license, so mainly interesting technology for the large MNOs. So the usual suspects, as we have in Germany, Vodafone, Deutsche Telekom, or also Orange, they work on these technologies. It's an international technology, it's international available. The security concept, security of these technologies is based on the 3GPP, GSMA, ETSI standards and papers and technical descriptions. So it's a pretty concise and good security model derived from the GSM, GPRS networks. We expect that this technology is a little bit delayed in comparison to the technologies in the unlicensed band. So when we look at LoRa or SigFox technologies, they are definitely a first mover advantage. They are 1 to 2 years ahead of the narrowband IoT technology. But we expect from a technology standpoint that narrowband IoT will speed up a lot, especially because the existing base stations of LTE networks can be used. So due to an upgrade of the base stations, which works in many cases, the NB-IoT will reach big coverage soon, or has already a good coverage, and will increase this coverage significantly even in this year. The first rollouts we currently see are already happening also with narrowband IoT, and narrowband IoT will be also then part of the future 5G standards. Maybe next slide. Here a little bit on the security concepts of GND. This security philosophy of GND is agnostic from the connectivity or radio technology. So we see that we need scalable security in the IoT endpoint. So for example, this can be a SIM card, and a SIM card is not a cost factor for us, actually, because a SIM card offers a lot of security services and offers a lot of convenience in operating key management. What we have seen with all these networks in the unlicensed band, such as SigFox or LoRa, they have no standardized process to roll out the authentication keys for the network and also for the end-to-end security. And a SIM card is a nice device to handle the key rollout process. There are other possibilities, but it's important that the key management and in conjunction with the key management, the key provisioning is handled in a very secure way. And this is definitely something which have the well-established cellular networks ahead. And then on top of the key provisioning and the key management, we place many additional security services at GND. We have already a lot in our portfolio, just to mention a few ones. One is the end-to-end encryption of IoT data, so that the data really is at the sensor encrypted, and only the authorized party then in the end system in the cloud has access to this data and can look at this data. That's one service, this end-to-end encryption. Another service is a secure firmware update of devices, so that only authorized person can reflash a device or can reconfigure a device. You can imagine that's very important when a device is 10 years or longer in use, which is foreseen for such LPWA devices, that maintenance operations have to take place. So we underpin this maintenance by the necessary security mechanisms that it can be done in a secure manner. And many others are in conjunction with our portfolio available. And I think that was already my last slide. Peter just gave me 10 minutes, 10 to 15 minutes. So I hope I did it in time. Thank you so much.
Okay, hello. I want to start my presentation or install my presentation.
Herzlich willkommen.
Genau.
Der Herr Glock lädt seine eigene, is loading his own presentation, wonderful. Das geht mit Control L, ne? And please, thank you for Stephan. I didn't think he was so quick. And yeah, wonderful. And now we would like to welcome Wolfgang Glock from the city of Munich. And here, doesn't work like this? Okay, well, you get the idea, okay?
Okay, so a warm welcome from my side. I'm Wolfgang Glock from the city of Munich. So I'm working for the city of Munich, and I'm IT strategist in the in one department, in the IT department at the city, and I want to introduce you to some different stuff. So we have seen in the presentations many things we can buy as a city, for example, and install in this infrastructure. I want to give a short overview on the activities on smart city, on IoT, and what we are planning the next years, and that with the example of a project called Smarter Together. Oh, wait a minute. No. It's. I have a problem with the presentation. The wrong one.
Ach so, das war jetzt die.
Das ist die.
Ich halt's mal. Wir haben ja Zeit. Dann machen wir die mal weg, sonst geht es. Und das auch. Ja.
Okay, that's the right one. Achso, wir können noch was brauchen.
Ja, danke schön.
Okay.
Schließen wir das und dann, ich mach schon.
Okay, after some technical problems, I'm sorry for this. This project Smarter Together is in the context of smart city, and that's why I want first to have a look at the at a kind of definition of smart city. When I started with the project, I go through the internet, and there you find many definitions, but I was not very happy with these ones compared with our project. So I found no definition fitting to our context, and what I found is that always the topics like energy, mobility, infrastructure, and people are mentioned in these definitions. And if you read a definition, you have to think about who is writing this definition. And if you have a look at the EU definition of this smart city, it's very compact, but it's in the view of IoT, of the IT stuff. And so I thought that it would be better, beside these big issues, to define some characteristics. So for me, the smart city is the quality of life, to improve this, the robustness of infrastructure, the services for the public, participation of the people is very important, transparency is a big issue, knowledge society, and support of sustainability as the cities are growing and growing, and we need to have solutions we can roll out on different areas and make our infrastructure better and reduce the impact of the infrastructure on energy, on mobility, and try to make the city more quality of life. So, what we are? Oops. Okay. This project, Smarter Together, it's founded by the EU. It's together with Lyon and Vienna. That's the so-called lighthouse cities. We have to define within 3 years solutions, white papers, and define things the following cities can move to their own city. That's Santiago de Compostela, Sofia, and Venice. And there are some observer cities outside of Europe, so Kiev and Yokohama. And who is from Munich here in the room? So these people may know this area. It's in the western part of Munich. It's the biggest area where we currently build infrastructure for about 20,000 people or 25,000 people. It's just started here. It's called Freiham Süd. At the moment there are only, there are stone and grass and all this stuff, and some buildings are started to build up. And within this area we want to do some nice things for a smart city, and that's in the context of mobility. There we want to build mobility stations. It's similar to the mobility station in Münchner Freiheit, where we have a first prototype, and within the project area we want to have another 8 ones. These mobility stations will combine public transfer, bike rental systems, and all this stuff together, and make and improve mobility in Munich. Then we have the energy sector, where we have refurbishment, and we want to reduce the energy consumption. And within this energy part, we have the first solutions using IoT technology to get information from the flats about temperature and humidity, to see the how the impact of refurbishment activities are on the environment within a flat, and give advices to the people living there how to improve their own environment. And the part I'm standing here for is the technology, and there we have 3 topics. That's a smart data platform, which is very important if you deal with IoT devices. So where will you put all these informations collected? That's the smart data platform. We decided not the term big data, because smart data is more focused on the solutions. Then we have the smart labs, and there on this topic I will talk a little bit more detailed. And on the other hand, we need devices, so everyone has a smartphone in his pocket, and that's the smart neighborhood app or city app we want to create and offer all the services we built within this project to the people. So here you see a map of the project area, and there you have the different parts implemented. So the yellow things are for refurbishment areas, where we have these smart home devices as well. Here we have the blue ones, that's the mobility stations to improve the traffic, and the red ones, that I will come soon. The topic of the speech was how the basic infrastructure can be used for IoT. And if we use these IoT devices, it's always important to have the desired solutions and the smart services for the people in mind, because it's it's useless to put some sensors on some object if we have no access to this information and have no useful things for the people living there. That's why we have decided to create a lamppost. Lampposts, okay, there are some lampposts already on the market. They are doing light, and they are getting more intelligent, so they have sensor systems integrated, and there you have charging system integrated. But these lampposts are rather expensive. So if you think about Munich, there we have 80,000 lampposts already installed. And if you want to substitute even 10% of these, that amount of money could be invested in other areas better. That's why we are looking for a rather cheap, so far, solution. And there we defined a lamppost which looks similar to the lamppost outside on the street. So I'm coming from the IT, and I have never thought about to get that personal relation to a lamppost like I have at the moment. So normally I would bring this one, there you have a picture of it, a real one-to-one model here on the stage. There you have, this is 2 meters high. There are different installation areas. There you have the light. Here you have the communication. We have already heard in the speech before about this Wi-Fi stuff. And there we have the possibility to install back-end system for the sensor systems installed outside of the lamppost. This lamppost is 10 meters high, and we have a smaller one to be installed in gardening areas. This is 3 meters. What we do with this lamppost, so we are looking within an open call process for solutions. The basic infrastructure we offer is the power. Okay, the light is installed. We have the Wi-Fi stuff. And then we are looking for solutions for this upper part. There we can have sensor systems, getting information about the environment, temperature, or the traffic flow within the area around. Then we put all this stuff to a smart data platform where we have the environmental data. We collect data from the people as well, from other sources, from general other sensor systems existing in the city. And one important question was always about data security and data safety and personal data. That's why we defined a topic called data gatekeeper. Here it's Datenwächter. It's very important if we start as a city to think about all this stuff, to handle the data very proper and keep the position of the city as a trusted partner very high. And these data will be moved to the mobility devices, that's the city app. Okay, and that's some examples for the things we would think about. So installing sensor systems to measure temperature and humidity, emissions. We hear all this stuff about Feinstaub or Stickoxide. The traffic flow is very important, and even we are looking for security solution or gamification solutions. There are some very interesting things out in the market. But anyway, if you have a good idea, we have an open call process started within 2 months, and please contact us. But the very important thing is on this, we can offer this urban infrastructure for the Internet of Things. We can do many, many things, very interesting, to make the city better and nicer, but we have to anfangen, experimentieren, mutig sein. I could not translate properly, I think, to English, and that's why to start and even accept some failures, but we have to do this. Thanks a lot.
Thank you very much, Wolfgang Glock. Yeah, the sound is back. So we managed to finally get the presentation running. We will continue our presentations with another perspective from the city of Munich, this time from Stadtwerke München, the utilities. We will have a use case or a practical example for smart metering. Ladies and gentlemen, please welcome Paul Nash.
Thank you very much, Peter, for introducing me and for the invitation, and thank you to all of you for staying here during lunchtime, actually, so I appreciate that, that you listen to it. So Stadtwerke München, my name is Paul Nash. We are the utilities provider, the local utilities provider of Munich, and at the same time the largest local utilities provider in Germany. So we keep the lights on, to keep it very short. And smart metering is the subject, and I want to make it a bit, you know, not too abstract. How do the things actually look that we're talking about? And what you can see up here is an electronic meter measuring the amount of electricity that you're using in your household. And if you combine that with a gateway, which is nothing else than a Fritz box you have in your house, you get a smart meter for electricity, or intelligentes Messsystem in German. So basically that's what we're talking about. And later on, that's only measurement, but what's planned for the future is that you combine that with ability to switch electricity in order to stabilize networks, electrical networks, and offer different business models based on that. So in the future, and I'll come to that later on, things you see here, not only around energy, but smart home and other things around that are thinkable, and actually we're working on it. And I know that a lot of you at startup companies are working on these business models. So it's a critical infrastructure. It's a highly regulated environment. It's not a plaything, if you want to put it like that. There's a lot of federal government and legal involved in that, and there's a reason for that, of course. The reason is that it's not only, we do have a lot of innovative market opportunities with smart metering, but at the same time there's a high responsibility. So I don't know if any one of you has read Blackout from Mark Ellsberg. If you do, please raise your hand. If you didn't read it, it's very good. And this is basically the scenario that we need to avoid. There's a high responsibility for all of you to keep the lights on in Munich and in the surrounding area. So we do have a lot of customers, nearly the amount of people living in Munich. It's quite a large company. It does not. It belongs to the city of Munich, but we are not the city of Munich. Quite some revenue, and as you can see, we run electricity, gas, and fresh water grids, and planning to roll out smart meterings in the range of about 72,000 over the next couple of years, and combined with around 850,000 electronic meters. So if you compare that, City of Munich has about 1.5 or something people living, so that's about the number of households you see there. So what does it mean for an IT organization? That's a visualization of the IT landscape and of Stadtwerke München and the dependencies of the different applications to one another. So as you can see, it impacts the IT landscape of Stadtwerke a lot. Introduction of smart metering will affect a lot of systems. You can read it here. We have an existing landscape of around 400 active applications, and a lot of that are touched. So we touch about 20 existing applications. We introduce new applications, I will show you that. And we decommission, of course, a few of them. So the message I'm trying to send, if you're interested, if you're an IT expert, there's a very broad range of possibilities at Stadtwerke München to basically cover and use your knowledge. So now to go a bit deeper, what does it mean to introduce a smart metering infrastructure at the back end? So that we need to run it at our back end to connect these smart meters. And the system that we're currently building up, it will go live this year, is what you can see here. I'm not going to explain all of the details. The only key messages I want you to see is that there's a back-end SAP system, of course, because we have to write invoices and all of the stuff that's handled there. And there's a huge system of different subsystems that we basically bought from Bosch, from the company Bosch, that does the back-end service for the smart meters. So these are the smart meters gateways, the meters there. There's a lot of interconnections for customers as well, of course. So there's an online portal, internet self-service for you as a customer. And at the end, we will have to, and it's a good idea, of course, get the data out for your usage as well, private usage. So the message I'm trying to send here is, if you're an IT geek, we can go very deep. The technology involved is high security, and there's a lot of deep technology that needs to be rolled out for that infrastructure. Okay, and that's actually my last slide. That's the future. What could be business models? As you saw, we are working with companies like Bosch and smaller ones, of course, very specialized ones. So if you are representative of a company like that, and you know that there's a business model that you have an idea about that would fit into that, please speak to us. These are a couple of ideas that we are already starting. So on the application or web side, there's the possibility of doing joint offerings like cross-selling, tickets, benefits. The colleague before already talked about smart cities, so there's of course interconnection to all of the things that a large city offers. And then on the back end, we will offer a standardized interface, an open API that you as an external third party can integrate to, and of course, given the legal aspects, can work with the data that we provide. On the back end, we also provide smart city login, customer profiles, communities, and of course all of the energy data that we as a utilities company use to stabilize the network are very valuable data that can be used for other purposes, given the legal restrictions, of course. So that's it, Stadtwerke München and smart metering, and I'm open to your questions. Please ask me. Yes? as I said, we're always open for anybody that has a great idea in utilizing that infrastructure. So please talk to us, talk to me. I will be around for. Yes, I will be around for the next. That's me. I will be around here. So just talk to me. Thank you. Any other questions? Okay, so thank you very much.
Thank you very much, Paul Nash, Stadtwerke München. The final talk of today's IoT track will be from a pioneering entity in that field. I'm very happy they could find a slot for us at TechDays today. And I would like you to welcome with me Oliver Niedung from Microsoft. I don't know why this is all moved, but it doesn't matter. Here he is. Oliver Niedung from Microsoft. He will start his talk while I load his presentation. Everything very dynamic in these tech days. Please welcome Oliver Niedung.
Well, thanks a lot, Peter, and it's a pleasure being here, and thanks for staying here, even though it's pretty warm outside. So we have 10 to 15 minutes and to cover a lot, so let me start talking about some of the key things we have actually been putting a lot of focus on recently. So some of the things I wanted to show you is, some of you might know Azure, which is our public cloud platform. And we're making actually that platform in a way that it really addresses a lot of the security as well as connectivity and artificial intelligence requirements from partners as well as customers. So I wanted to show you a couple of the things we're working on here. In the 38 data center regions, actually, we have way more data centers. We have over 100 data centers right now around the globe. Recently announced also South Africa, so that's constantly growing. We also have 2 in Germany, one in Magdeburg, one in Frankfurt, actually, and it continues growing. And from all the many certifications we're going, a couple of them are specific also to some of the German laws here. One is the German IT Grundschutzworkbook, as well as you still see the EU model clauses right here. So it's very important for us that we can support our partners and customers in their certification and in their legal requirements, whether the data needs to stay in the country or whether they have from their industry specific requirements that we typically try to address here mostly on the global as well as industry specific certifications. Now, when we then look into the recent announcement we've had, and we've had a bunch at Hannover Messe this year and beyond actually, some of the things I picked here is actually, besides, I wanted to talk about Edge. We don't have the time to talk about that. I want to talk about our SaaS service. So we announced our own software as a service, so a complete solution with IT Central. But the one thing I felt would probably resonate most here is actually the stuff we're doing for automation, for the automation industry. And this in particular is we provided one of the pre-configured solutions for connected factories. And this goes hand in hand with all the activities we're doing around standardization through OPC UA. Now talk about OPC UA. Who does know about what OPC UA is? Hands up, please. Okay, there's a lot of work to do, but thanks for those who know about OPC here. So these slides are actually from the OPC Foundation, so the Vice President gave that to me so I can talk about it. So if you're not familiar with OPC UA, so this is Foundation slides, the quality is black and white here, so you get it clear here. But what OPC UA is, it is the standard if you want to be Industry 4.0 basic compliant from now and in the future. If you haven't heard about it and you're working in the area of automation, look at that standard because it is a must going forward. So what it really does is, on the one hand side, it is something which is independent from the transport layer. It is an architecture. It is not a protocol, though the protocol part is the most essential part within it. And it is also the biggest reference here for in Germany. It is the standard for Germany, but also in the US, where it actually was created first in the US, and then it came to Europe. And now also Korea, Japan, and China actually decided to take this as their standard for all their industrial IoT activities. And also, as I mentioned, it's a requirement. You can read this in the ZVEE document, actually, and where it is required. There's 2 requirements, actually. So we invested a lot. Actually, the research team that is developing for Azure OPC UA stack is actually also sitting here in Munich. So we have 2 facilities, one up in Schwabing, which is Freistadt Schwabing, and the other one is actually in Lehel. So in Lehel, we have our IoT Insider Lab as well as our research team, and they're working day on, day out actually on the integration with OPC UA. It is actually reviewed by the BSI. They like it, so this is also why they are recommended for Industry 4.0 areas. And what is essentially, it really provides authentication, signing, and encryption guidance here on that side. But not going too deep, we like it. So we're investing actually quite a lot of resources because it's not just important for cloud connectivity, but it's really, we heard a lot earlier today also about the need of standardization in the area of IoT. We looked at this standard. It is an open standard that gives everything that we actually require. It is open, it is extensible, and it is secure. Most people still actually, there's a flag, no security within OPC UA. This is still mostly switched on in most implementations. We strongly recommend not to use it. What you have seen actually in the slide before was OPC UA enables actually IoT by design, security by design. Now we wanted to take this on a different level. When you look at the typical automation pyramid, sorry, that bill's a little longer than I was hoping for. So usually, when you look at the automation pyramid, so typically what you see on the lowest level, these are special protocols that are usually used. Now, above that, you find OPC UA pretty much everywhere. So you find it in the MES, talking to the PLCs. You find it then in the ERP typically. And then actually on top of the traditional automation pyramid, you actually find the cloud connectivity that is using a more modern OPC UA pub-sub architecture that we've also actually released at Hannover Messe. Now, the thing we did actually for integration here is we provided something we called Azure IoT Gateway SDK, which is now, we're extending that now to the Azure IoT Edge service actually. Now we have the OPC UA client module actually so this is actually the factory floor still, so we're in the factory here. So we're actually enabling the connectivity, so you can take these sources from GitHub under open source on your platform, whether it's Windows or it's Linux or other platforms. We have this, most people use our .NET implementation, but we also have that for Java and some other languages actually, including ANSI-C. And then actually from there you can then easily connect to our Ingress service, which is Azure IoT Hub. And from there you can either go through the hot path analytics if it's time sensitive, near real time, whether you need big data and long-term compute, which is often machine learning, or something mixed. Sometimes you want to have hot requests from machine learning here. And then from there actually we call this actually more a warm path here. So this is something where we have the integration actually of OPC, of the OPC stack in Azure. And from there, you typically go into your business logic, where we don't have the time to look into that today. Now, what we delivered there is, what I mentioned is, first of all, the Azure IoT Suite is something where we want to make it easy for people to use these sources and free to use them. So we put the things here under open source. We have 3 pre-configured solutions. One is for remote monitoring, one is predictive maintenance, and the recent one is Connected Factory. These are sources you can go into GitHub. For those who are developers here, go into GitHub, you can download them, you can play with them, you can even contribute to the community and actually add your own source code to it, and it will be reviewed and so on. So it is under open source, and the big change we made here is we made it secure by default. So everything you connect there is always with OPC UA security on, so there is no way to switch the OPC flag off as we have it here. Now, and I wanted to give you a little bit of visuals. If you had more time, maybe you can do it in the afternoon for those who come to my workshop also later on. This is actually what you will see in the pre-configured solution. From that, you can then actually drill down. So you have a map with your manufacturing sites in this pre-configured solution. We also have them represented here in a list. You typically see the alerts also, if there are alerts in the factory. All of the communication, again, happens through OPC UA. and then you see all the key performance indicators. Typically, these are OEE, so the overall equipment efficiency. If you're managing a production facility, you're very familiar with these KPIs actually. So this is what we have put into the first page here, and from there actually you can extend it. When you go into that sample, actually you can drill down to the robot and see actually all the parameters, all the activities in the robot, into something I also mentioned on the first page, no, on the third page actually, which we call time series. So it is pretty difficult to survey thousands of data getting in and out and visualize them. So this is why we have also provided time series as a way. So you have the integration from the fabric to the shop floor to the robot, and in the robot actually, or whatever the device is that you're either controlling or you get the sensor data from, actually from there actually you have then the ability to visualize it. And the biggest difference here is actually we have command and control. We're not just taking the information, we also have command and control, so we make device management and so on, actually device provisioning and so on. So these are the 6 steps typically that we recommend people to take if they want to actually get started with the pre-configured solution here. And these are actually the sources for those of you who are interested can download the code and start getting in there. Couple of last slides before my time's probably over soon. Some of the things we want to make it super easy on the one hand side to play with certified partners. So we have a catalog of partners. There's a couple of hundreds of partners in already, if whether they're ecosystem players or whether they are actually device manufacturers. So you can find them actually in the internet. So, and we make it actually a lot easier right now for people to certify that and also to find the devices by hierarchy here. Those of you who are not yet familiar with Azure IT, and there's still quite a few, these are the sources you might want to go to learn more about Azure and Azure IT, how it can actually help you. For those of you, again, who are developers, that is a good way for you to actually start a good career with many customers, as we're actually in so many IT implementations these days. Working on that, actually getting ready for it is probably something that will help you a lot in your career. And also, we want to make sure how important that is. We're working with pretty much all the key automotive manufacturers on integration of their production into Azure. And this was also an example, actually, from a non-automotive area, actually. So this is what we did. I showed also at Hannover Messe as one showcase, integrating the OPC UA stack with Berger and Osram. So these things actually make a lot of sense because you can, by default, take any controller, put on the OPC UA stack, and then talk immediately to the device. So you take standard solutions, and this actually makes it very quick, actually, in your implementation. And one of the things we use also there is a little variable. So for those of you who are here still at 2:30, want to see and hear a bit more about that one, it's a B2B variable running Windows 10 IoT Core, our free operating system, actually. And so that is using Microsoft Cognitive Services. So you could talk to the device, and it would actually, from what you're saying, it would control your smart lighting in the manufacturing plant. So this is what we were showing, and all of the communication going through OPC UA. With that, I'm actually done, because I understand I was the last between the lunch and the shows here, if that is still correct. It's not correct. That's what was my initial. So I hope you can stay with us. If you have any questions, I would like to refer to try to grab myself in the break right now, or you might want to come actually at 2:30 to my workshop. We're going to talk about 2 things. One is the wearable implementation, and the second part is actually secure connectivity and actually advanced analytics in Azure. Well, thanks a lot for your attention. Really appreciate it, and would love to see some of you and talking about some of the implementations. Thank you.
Thank you, Oliver. So he will be available in the cool place later on in the Tonhalle.
Wonderful.
In the afternoon. This is the hot place. The other is the cool place.
For the hot stuff. Right?
Yeah, exactly. This is the hot stuff. And over there you see the cool things. Thank you, Oliver. We will have a special topic session now before lunch, but nevertheless a very interesting and exciting session. So it's about analytics and intelligent analytics. I forgot the real title, but Florian Wolf, the next speaker, will tell you better. Florian Wolf is the founder and managing director of Mergeflow and has a very exciting view on digital trends and, let's say, digital developments. And please welcome Florian Wolf while I will start his presentation. Please welcome. There we go.
Thank you. Thank you for the invitation here.
I have to put it in presentation mode, then it works. There we go.
Okay. So, my name is Florian Wolf. I am founder and CEO of Mergeflow. We are an analytics software company based here in Munich. And today I'll talk to you about innovation intelligence for the digital age. So, innovation intelligence really is a central activity in any modern enterprise. For example, in corporate strategy, idea triage is an important activity. What is that? Imagine you have, let's say, 10 or so topics or technologies that you could focus on, but you only have the resources to do 2 of those. So how do you make that choice? How do you make a fact-based, rational choice of how to rank and sort out those ideas? That's idea triage. R&D executives, for example, need to be able to discover technological opportunities outside their organization that might help them, for example, develop new products or solutions better or faster or both. And corporate investing, of course, you have to be able to discover potential investment targets. And very often those are companies that are relevant, but that you might not even know do exist. Industry analysts have to understand market structure. For example, who are the players in the market? How are they related to each other? How big are markets? How does the market develop over time? And so on. Now, I'd say that because of the connected world, meaning the internet, that really requires that we take a new approach to innovation intelligence, because there's just so much information and at such a great speed and diversity that we could tap into that we cannot just do this manually anymore. If you look at innovation intelligence over time, in the past, I guess you would, for example, go to the library if you wanted to know something, or then you could go to proprietary innovation information providers and, for example, buy a report on an industry branch or so. Then came innovation consultants, where the idea is basically that you pay someone to research a technology or innovation field for you. And now we see what we call machine-augmented innovation intelligence. And the idea here is that you combine human and machine, kind of taking the best of both worlds, because machines or software can deal very well with large data or large amounts of data, but humans are very good at, for example, drawing causal inferences, interpreting and evaluating things or information. So what do I mean by machine-augmenting innovation intelligence? At Mergeflow, that basically falls into 3 categories: capturing, analyzing, and discovering. So in order to capture information in the first place, we have built a set of distributed domain-specific crawlers, APIs, and other technologies that collect raw information, meaning text usually, 24/7 and fully automatically. Then once we've collected that information, we have to do something with it, of course, and to that end, we have developed algorithms that can detect entities, for example, people names or company names and so on, or data, such as financial funding, market size information and so on, from those raw texts. And then in order to enable the human who is sitting in front of our box to actually make discoveries, rather than just presenting them with a list of documents, we present them with interactive visualizations, because that lets you focus on the interpretation of the data rather than collecting and cleaning up your data. So, of course, we do not monitor the entire web. Rather, Mergeflow collects a technology-relevant subpart or subparts of the web. And what you can see here, so those are different categories of information that we collect, and the numbers are sort of averages of what we collect in new documents per week. I guess it's obvious that nobody can read 30,000 new scientific publications per week, but the problem actually starts a lot sooner than that. In the beginning, we only had technology licensing offerings, and that's just 250 documents per week. That sounds like a very small number, especially in the age of terabytes of data, big data and whatnot. But the problem is those sources, or this information is spread across hundreds of databases. So if you did searching manually, just one search can easily take you 2 days or so to complete, and I guess it's obvious that that's not sustainable. Just in order to show you how this works or what kind of results you can get out of our platform, I'd like to show you 2 examples that are kind of at the opposite end of the spectrum of typical use cases that our customers have. One end of the spectrum would be tactical sourcing. As an example, I chose, imagine you want to find new methods for testing malaria. You might want to look for companies or experts and so on. And at the other end of the spectrum, for strategic assessment, I'd like to compare cloud computing to edge computing. Now, for example, if you look the malaria testing use case, basically what you do is you enter malaria testing, maybe a couple of synonyms, into our platform, and then Mergeflow identifies companies in your result set that develop new malaria testing methods. And if you look at that screenshot, you probably don't recognize most or none of those companies, and that's kind of the point, because that's what you want to discover, is companies that are relevant in this space, but that you might not even know do exist. And then, of course, it's up to you as a human to then dig deeper and look at what those companies are actually doing to judge whether that is relevant to what you are trying to do. Of course, this is really just scratching the surface, right? You would go much deeper than that and just finding a couple of companies. But in the interest of time, I'd like to move on to the strategic assessment example. In order to do strategic assessments, people often use what's called the size growth matrix. And usually that's made by hand, by consultants, for example. And we have developed a software component that can do this automatically, and based on information from science through business, through patents and other things. And so you can see here the x-axis represents growth. It's a log scale, so things are bigger than they actually look here. And the y-axis is the growth. And so I added blockchain just for comparison. So you can see here that edge computing is pretty small still, but it's growing rapidly, whereas cloud computing is very big, but it's not really growing. It doesn't shrink, it's just that the growth is slowing down. So now you might want to dig even deeper, because I'm showing you some slide and you think, well, what is driving the growth of edge computing, for example? So then you can dig deeper and split it up into the different components, and then you can see, in real life this is interactive, so it's easier to split apart the individual lines in this graph. But so you can see that the growth of edge computing is driven mostly by science, industry, tech blocks, and investments, but not really by patents, for example, which here are in the lower left corner, indicating that they are small and not really growing. And then you can dig even deeper and ask, for example, so VC investments, who is that? What are the companies that are being invested in? And then you basically just click on that, and then you see the companies, the VC-backed companies in the area of edge computing that Mergeflow has identified. And just like probably many of you didn't know who Mergeflow is before today, probably many of you also don't know who ZenLayer is, but they got 10 million in funding. So this is a way also of discovering players in this field that you might not even know yet. Same for science, because, like I said, science is another one of those growth drivers of this topic. Here you could dig into author social networks, because from those scientific publications, Mergeflow extracts author networks. This is basically co-author networks, and so you can look for people that play a central role or have a central position in those social networks rather than sit in the periphery. And then you can go even deeper and look at the actual publications. Now, I've been talking a lot about software, but like I said, it's machine augmented, and so the human aspect is really very important. In order to to do this effectively, it's really important to do new things and not do what everyone else is doing. And that's what I like about this photo from the Jet Propulsion Lab, because if you just look at where those guys are looking, you can probably guess who's probably going to be the more successful innovation intelligence analyst here. So do unusual things, don't look where everybody else is looking. That's the human aspect of this. I'd like to, these are organizations and companies that we have the privilege of working with. I'm just showing you this so that you know that this is not just some abstract concept or idea that I'm talking about, but it's actually implemented and it's being used by serious people working in serious organizations. And with that, I'd like to close and thank you for your attention. If you have any questions, I'll be around for a while, so find me if you can, and I'd be happy to talk to you. Thank you.
Innovation Intelligence, Florian, Wolf, thank you so much for coming. Thank you, Florian. So, a morning highlight waits for you now. When I asked Rupert Deger to come to give a presentation at TechDays, I actually did not expect him to accept. But lucky enough, he accepted and he said, yes, I will come. And here he is. You will know why I'm so happy that he could make it to be here by his presentation himself. He will take you to a very nice little journey from the mobile perspective, the automotive perspective, a very disruptive and clever work they are doing. Please welcome Rupert Deger. Meanwhile, I will also charge a movie, so he will start talking and I will try to make the additional elements. Please welcome Rupert Deger.
Thank you, Peter. I was happy to accept. It's a good excuse to be home a day earlier or two than usual, as I spend the week usually in Aachen, Germany. So, disruptions from Engineering Valley. What is a disruption? Well, maybe 30 years ago almost, I worked as a summer intern, as a student in the Siemens plant for mainframes in Augsburg. Do you still remember? So, I mean, that's the concept of disruption. Engineering Valley is not the Silicon Valley. We don't deal a lot with silicon up there in Aachen. I will go into that in a minute. And my name is Rupert Deger. I work in Ego Mobile, which is an electrical car startup company from Aachen. If you read the news paper this week, I think, there was a little article in the local chapter around Deutsche Post announcing together with Mr. Reiter, the Lord Mayor of Munich, the first 30 electrical postal distribution vehicles, the street scooter, to arrive in Munich. There are already several thousand on the road in Germany. And that vehicle is produced in Aachen. And it has been developed in Aachen, and it was in the hands of the founders until end of 2014, before their main customer, Deutsche Post DHL Group, decided to acquire the whole company to ramp up to serious production, mainly for displacing their current delivery fleet for parcels and letters in the cities and in the countryside, where electrical, purely battery-driven vehicles are only and mainly advantageous for all sorts of reasons, including the technology, the total cost of ownership, the lack of pollution, and labor productivity. So when we come back to the Engineering Valley, then that's basically where the street scooter originated since 2010, and where we founded then Ego as a subsequent startup in 2015. So this is right at the Rheinisch-Westfälische Technische Hochschule in Aachen, the RWTH. There's a Europe-wide unique setting as a campus The campus doesn't mean the location of the university. It means it's a field of interdisciplinary collaboration between science and industry with significant strategic investments by industry players and technology providers. So when you look at this photograph here, you see a little bit the structure, but by the way, this is Holland, and over there is Belgium. So I sleep usually in Holland, and then it's nice, people are very relaxed there. And then I work up here in this area where we have the headquarters of EGO and significant manufacturing capacity. There are other transformational topics around, including biomedical, including photonics and so forth. The whole concept is actually there's going to be almost 20 of these clusters, 2 billion invested, 10,000 jobs. And the overall idea is to arrive at an offering which we call Innovation Factory. Innovation Factory would be a clinic for companies to move in with their new projects before they bother dealing too much with ambulant consultants. Having the right kind of infrastructure and the right kind of expertise really around them, which is already possible today, and we do it to ourselves. So this is where we are currently located. So this is the production engineering cluster in that campus setting, and small parts of this building are the EGO offices and EGO showroom, and the larger part is the EGO ramp-up factory. Now, what is electrical cars all about? It is not about the idea to say, I have a horse cart, and then I have a horse cart with a combustion engine. And now I have a car with a combustion engine, and now I simply replace the drive technology and make it electrical. That's the same idea as trying to make a car from a horse cart. So when we look at the boundaries and the possibilities of electrical technologies, we first need to respect them and then think about the value proposition. And not try to make it another derivative that fills more of the same into the more of the same factories of the big OEMs. I think that's at the moment the fundamental blunder in the electrical market. That's why you don't buy electrical cars, even if you get 4,000 euros subsidy. So our purpose is basically to provide vehicles that are fun, that are practical, more practical than average, and that are most affordable. And this is possible based on understanding the customer. So let me understand you while you're listening here, not only listening. Who of you owns in their household more than one car? Raise your hand. More than one car? Okay, not too many, okay. And for the second or third car that you're using, who is using it mainly for short trips, like shopping, commute, let's say downtown or to the S-Bahn? So those who had raised your hands. And so I have already a clear target segment here. And when we look at then how do you park it, I mean, is it always the same place, at work or at home? Yes? So fundamentally, then you have, for such mobility purpose, you don't have a lot of limitation from electrical, because the range doesn't matter much for the short trips, and the charging doesn't matter much. Every car stands around 90% of the time. You just plug it in at night. Now, the only remaining question is, how much would I pay? And I would say 16,000 before subsidy is not too much. So this is the concept of the EGO Life. And we are here very happy to say that we're going to start volume production in the second quarter of 2018, and that the first year is almost already booked with pre-orders. So you can go to our website and check for pre-orders of the EGO Life. So why can we do that? So I like the picture of the preceding speaker where the guy looked in the different direction. It's a little bit of a human aspect, looking in different directions. And our main premise is you cannot start up an automotive company if you don't have a lot of money, if you don't do things different. So it would cost us billions to do it the regular way. After all, this is hardware. Now, the fundamental thing is that the investment into a car plant amortizes only after hundreds of thousands of units, because you have heavy-duty investment in brick and mortar, like press plant, press tools for stamping. You have the body in white, the welding, you know, the robots there, the paint shop and stuff like that. None of them that we need, because we simply, you know, not too many have raised your hands for our target segment. We respect the fact that it may be rather small unit volume to start with. Actually, our series plant is built for 10 to 20,000 cars a year, and it still needs to amortize. So we simply changed the product architecture to more of a race car architecture, which means you have a frame, in our case made of aluminum, that protects you, that protects the batteries and everything. That is a very electrical, optimized product architecture, and that then is covered on the exterior side with thermoform plastic parts, where the tooling costs in the single-digit % range of what the usual tooling for the stamping would cost, for instance. So we're optimized for low volume. We're also optimized for electrical, so you find very much space left for 4 seats, real 4 seats, and how you would want to use it based on the fact that on the bottom you have all the batteries and also the rather small electrical drives. I don't go in this time into all the details of the features, so please refer to our website. The second major thing in making things agile and low capex is our development process and the interaction between physical and digital. So in our case, car development projects costs about 1/10 of a regular car development project. Not only because we make simpler cars, but we also try to apply Scrum to our hardware processes. And if I may, maybe we can start the video. Could you help me, Peter? Could you help me with the video? So I just want to elaborate a little bit on what agile means to us. So we have started doing complete development of vehicles on the digital level with CAD and everything else, electrical CAD and so forth. And we decided to work on prototypes from early on to validate and to, you know, really get a feeling for what we do as our first car. And what you see here is basically an augmented reality display on top of our physical rolling chassis with some product data, where you see here also combination with requirements data, with bill of materials data, with drawing data. So we have the whole digital documentation of the car in our hands in a single source of truth, as we call it, and we put it on display here through augmented reality. And what you see then here is our first exterior design, the blue one, which was a bachelor study actually, and the next one also, student work here, was our second one, and it still fits the rolling chassis here quite nicely, as you see. And this is our third one. This is Italian design. That's how we go to market, and you see it's bigger than this rolling chassis. So what I wanted to say with that is we have been using partial prototypes for interior, for exterior, for the technical side all the time, and we have been iterating quickly on each of these things. We have then made a decision to change the format of the car massively in December, and we've building complete cars since April, or released the first one end of April. So we go very fast. We don't go traditional. We don't go complete requirements. We go agile. And that brings us down to earth very much and is way beyond the performance of the traditional sequential car development processes. So, third example, we're just building our series plant in Aachen with the support of North Rhine-Westphalia and the city of Aachen. And that is also going to cost a fraction of a regular automotive plant. So when you hear like some big brand has opened in the southwest a new transporter plant and the investment was something short of $1 billion, we couldn't afford that. This is going to cost 30 million. okay? And we are making 10,000 units per year per shift there. So if we do 2 shifts, we can make 20,000. And the interesting thing is, this is our original. I mean, we have other facilities now. We have a demonstration factory, we have a ramp-up factory, so we can do the bodies and the complete prototypes ourselves for small volume, but this will be the serious plant. So we'll have that structure finished in October. We'll then equip it, and then we'll start serious production in April. The idea is, this is our original. So we will not create massive plants. We will create a network of microfactories, also international, and we will not create them ourselves, but they will create it based on our franchise original. So this means China, India, Mexico, whatever. Franchise partners can join us, create their own business in their own country, and receive on our blueprint cloud everything they need to be doing. And we control it also this way from an IP perspective, which means we are cash positive on international expansion strategy from the first day. So another example that is evolving here quickly is not just individual traffic, like I explained for the Ego Life, but more like the question of what is the transportation of the future out there with electrical and autonomous means. And ZF and NVIDIA both have come to us and say, why don't we create a little shuttle that has the potential to be autonomous? In fact, we know how to go autonomous. Deutsche Post has a site near Aachen where they have a village, a mock-up village, where they do already robot distribution. This means it's not hard to configure. It's harder to, be ready with the product, and then really hard to say, ready for the traffic. But if you think a little bit different, like on the picture of the preceding guy, think, why don't we have a bigger pedestrian zone? Why not everything inside the Mittlere Ring? And why not call an autonomous shuttle like Uber? Done. But that is then not a business between you and I as business to consumer or fleet customers, which we address with all cars that we're having in private or public sector. This would be an infrastructure play. And this is very, very hot in the world. Everybody has the same problem. We need to get rid of the cars in town. We cannot afford to dig another subway. Last thing around digitalization, as this is the topic of the day. I showed you a little movie, and all of our processes are supposed to be cheap and agile. So we are using a term which is now coined Internet of Production, but forget about terminology. There's so many 4.0 things. The main thing is we basically see process as circular. We have it in the design and in the manufacturing phase and in the user phase, which comprises what you would say sales, marketing, service in the 3 columns. If you go row by row, you basically somehow you collect data or hold them in traditional systems. You then would aggregate and analyze, and then you would bring it to usage in the processes. Very much of the new stuff you don't really want to drive through traditional database systems like an ERP system or a product lifecycle management system or a customer relationship management system. That's basically for us on the bottom, just another source. And so we are working in my role also as a CIO and as a head of the European 4.0 Transformation Center at the Aachen campus here on making this very tangible. So I invite you all to Aachen because it's really very hard to explain everything on PowerPoint. It's very easy to understand when you see it. Next opportunity is always open, and the next event opportunity is 27th, 28th of September. We do a practice forum, Realize Digital Transformation. And here you see the Internet of Production here in action between the development cycle, between combining development with manufacturing, having a high resolution monitoring of manufacturing, also on an app level. And then in this case here, user, we didn't take in this photograph the usage of our cars, but the usage of our machinery. And we are working through that. And as you can see, I mean, basically a startup coming from the engineering side into the selling and manufacturing and selling side would go along these diagonals from the bottom left to the upper right overall. Example for us, weight management has been very important for us. So in detail, you would see here our weight management app that we put on top of our development systems, and where we made the engineers maintain all the forecast information about weight, and where we're looking at in a real-time basis on such information. And we have all the technology with our partners here in-house. So the Aachen campus is very open for any company to offer partnership. We call that matriculation for a couple of years. It's very fancy, very creative, very interactive. It's the place of intended coincidence. I can tell you something very special is happening every week. I just don't know this Friday what's going to happen next week. Thank you very much.
Thank you very much, Rupert Deger, University of Aachen, at the same time CIO of Ego Mobility. So you want to buy one of these smart designed products, approach them, we'll be happy to sell them. Thank you so much for coming. So now this concludes the morning track of this session, and also of the Innovation Intelligence special topic session. We will have a universal lunch break now. Lunch will be served at the Turnhalle. I think it's some oriental combination that you might be able to enjoy. In the afternoon, we will have on this stage smart manufacturing. We will have again use cases and practical insights. The stage moderation will be done by Thomas Kinkeldey. He is my colleague at VDMA, our partner for organizing this track. If you are looking for blockchain or other remaining other subjects, they will be also at Turnhalle in the afternoon. In the evening, everything will conclude back here with, and we just ordered it, some free beer, live music, and networking and party and music. Thank you so much for attending. See you in the afternoon. Thank you.